Okay, to find the product or quotient of a complex number, we can change it to trig form and then use these formulas instead of having to FOIL and simplify that way. So on your 6.1 assignment, you had problems where you were multiplying complex numbers together. You had to FOIL it out. You had to take the I squared and turn it into a -1, and then combine like terms and simplify it, right? Or to divide, you had to actually multiply the top and the bottom by the conjugate, and then simplify whatever needs simplified to turn it back into standard form. Yes? Does that sound familiar from your 6.1 assignment, those of you who have done it already? I guess I didn't come around and stamp your papers. We should do that. Anyway, so these are product and quotient rules that might possibly make this process easier. If you're trying to multiply two complex numbers together, and we keep using z, I'm not sure why. Basically, if you're multiplying one complex number times another complex number, so z1 complex number times z2 complex number, first of all, you take their radiuses and you multiply them together. So the radius for one complex number times the radius of the other complex number. Okay? Then, all you have to do with the angles is add them together. Okay, so that is multiplying two complex numbers. This would be if it's in trig form, and you would do this process instead of FOILing and simplifying your complex numbers that way. Alright, now let's look at the quotient rule. That's where you divide. The quotient rule is the same exact pattern, only instead of multiplying and adding, what do you think is going to happen? Dividing and subtracting. So it'll be R1 divided by R2, and then cosine theta 1 minus theta 2 plus I sine theta 1 minus theta 2. Alright, so those are the rules. And no, you don't get notes to use those on your test or your final, so you just have to remember them. Okay, let's do an example. Find Z1, Z2. It's not my rule. If it was my rule, I would let you. Because my teachers at Snow College always let us have a cheat sheet.
Have you talked to them and they're just like, no?
Yeah, Slick just wants to be strict. I guess it's probably, I get the impression, and probably I shouldn't say this on video. That Salt Lake Community College has kind of always had a reputation of being, you know, a junior college, which it is, and less of an education. So I think they want to make things stricter to prove to people that you'd get as much or better of an education there than you would anywhere else. Salt Lake Community College. They want to have a good reputation for having strong students come out of their programs that don't require cheat sheets, I guess. I don't know. Okay, so following the pattern of the rule we just learned, if we wanted to find the product of these two complex numbers, what would we do? Okay, multiply the radiuses first. So 4 times 8 is 32. Then we add the angles together. So both of them are at the same angle. That's interesting. So it's just going to be cosine of pi 12ths plus pi 12ths. Well, what happens when you add 2 together like that? Good. So you have 2 pi 12ths, which is the same thing as pi over 6. So that means the other one is also going to be pi over 6. Because the nice thing is, once you figured out one of them, you automatically have the other one, because they're always the same. Okay? Now, if you want your answer left in trig form, guess what? You're done if you want your answer in trig form. So how can you tell if you want your answer in trig form or not? They usually tell you. They usually say leave your answer in trig form, or they'll say put your answer in standard form. So that would be trig form. But let's go ahead, just for kicks, and find the standard form answer. Okay, what would that be? We just learned how to do this. So yeah, we need to find the cosine of pi 6. What would that be? 30 degrees, so cosine square root of 3 over 2. So 32 times square root of 3 over 2 plus I times the sine of 30, which is 1/2. And we have to distribute the 32. So if we distribute the 32, we have 2's on the bottom that will divide into the 32. So we'll be left with 16 square root 3 plus 16I, and there's the standard form. So based on how big those numbers are, if I had actually done this by foiling, I would be multiplying together kind of big numbers, not huge. Do you think that took any longer than foiling it out and simplifying it? It maybe did because we're learning. But if it was already in trig form, then doing this way might be faster than the way you did on your last assignment. I'm not sure or not, but it could be. Okay, let's do division. But guess what? I'm not just going to let you use the last answer. We're going to do something different. Wouldn't that be nice if I just let you use the last one? I'm not. We're going to do different ones. We're going to say z1 is negative 2 plus 2I square root 3. And z2 is square root of 3 plus I. So if this was the 6.1 assignment, in order to do this problem, you would be taking negative 2 plus 2I square root 3, and you're dividing by square root of 3 plus I, but then you would have to do the conjugate, so you would have to multiply by square root of 3 minus I over square root of 3 minus I. You'd have to FOIL everything out, simplify, divide it, put it in standard form. Does this sound familiar, those of you who did 6-1? That would be the process, right? Okay. Instead, what we're going to do is change them to trig form. So that's just a little side note there. We're going to change these to trig form, and then we're going to use the other formulas. All right. So let's start with z1. z1, we start by finding r. So r1, and r1 would be found by doing the square root of negative 2 squared plus 2 square root 3 squared. That sounds familiar. I think we kind of had those same numbers earlier. And negative 2 squared would be 4, and wasn't 2 square root 3 squared, wasn't that 12? Which gave us 16, which is 4. Is that right? Then I'm going to just quickly graph it. So that's in the second quadrant somewhere. So to find theta, I do the inverse tangent of 2 square root 3 over negative 2, which is the inverse tangent of negative square root of 3. And the inverse tangent of square root of 3 is a 60-degree reference angle, but it has to be in the second quadrant, so it's going to be 120 degrees. Do you see how I figured that out? So that's a 60-degree reference angle. If we were just finding the inverse tangent of the negative square root of 3, the answer would actually be negative 60, because it would be quadrant 4. But because we graphed it and we know it's quadrant 2, we do quadrant 2 instead. Okay, so that means that z1 is 4 cosine 120 plus I sine 120, correct? So there's one of our two complex numbers all figured out. Now let's do the next one. Z2. R2 would be found by doing the square root of the square root of 3 squared plus 1 squared. So square root of 3 squared is what? 3, and 1 squared is 1, so we have the square root of 4, which is 2. Alright, now let's graph that. So the point is at positive square root of 3, positive 1, so what quadrant is it in? Quadrant 1, so that'll be easy. So then we do the inverse tangent of b over a, so 1 over square root of 3. That means it's square root of 3 over 3, which is a 30-degree reference angle. And since we're in quadrant 1, it's simply 30 degrees, right? So that means Z2 is 2 cosine 30 plus I sine 30. Alright, now that we've found them in trig form, we now use the formula, which says if we're doing Z1 divided by Z2, we take R1 divided by R2, right? So what's R1? 4. What's R2? 2. And then we multiply by cosine of 120 minus 30 plus I sine 120 minus 30. And that gives us trig form. 4 divided by 2 is 2. Cosine 90 plus I sine 90. That would be in trig form all done. Should we go ahead and find standard form? I think it's going to be really easy. So standard form would be 2 times the cosine of 90. What's the cosine of 90? 0. So 2 times 0 plus the sine of 90. What's the sine of 90? 1. So it's going to be 2 times 0, which is 0, plus 2 times 1i. So what's our final answer? 2i. So if we had followed through with this thing right here, it should have eventually simplified to a simple 2i. Is it possible that that would be easier than changing them all to trig form and doing this way? Very likely. But if they're already in trig form, then using this method is really easy. Right? So there's a trade-off. Anyway, when we get to next section, we do powers and roots. It's definitely a lot easier to do it this way in trig form than it would be. Like if you had a complex number and you had to take it to like the 5th power, then you would be foiling a binomial that's a complex number with i's in it 5 times. Foiling anything 5 times would be a nightmare, right? But with the power and root rules that we're going to learn next time, it makes it really easy. Kind of like the multiplying and dividing were easy when it's in trig form. Okay, so this is going somewhere that makes this stuff easier, and I know some of you are thinking, when am I ever going to use this in real life, because this is imaginary numbers after all. We're doing all this on imaginary numbers. I don't know. I don't know what job uses this. I just know you have to know it for your final. So if for no other reason, you're learning it for the final, okay? I would love to know what real life application this has, though. That would be great.